In this video, I will explain elastic and inelastic collisions. Let us talk about momentum and kinetic energy in collisions. In all collisions, momentum is always conserved. This happens because Newton's third law is true at every instant, so the total impulse on the first object is equal and opposite to the total impulse on the second object. Kinetic energy may or may not be conserved due to deformation of the object's release of heat and sound energy. If kinetic energy is conserved during collision, it is called elastic collision. If not, it is called inelastic collision. For a perfectly elastic collision, we have total initial momentum equals to total final momentum. Let us take out m1 common and we move the terms containing m1 to the left and the terms containing m2 on the right, and we take out m1 common, so u1 minus v1 will be equals to m2. On the right side it becomes v2 minus u2. This is our equation 1. Now for kinetic energy, the total initial kinetic energy will be equal to total final kinetic energy. We remember the equation for kinetic energy, half times mass times velocity square. So we apply that to objects m1 and m2 for initial and final values. You can simplify this by removing the halves, is common on both sides, and then again we rearrange it in the way we did for the momentum. The terms containing m1 on one side, then removing m1 common, and the terms for m2 on right side taking out m2 common. So we have m1 in the bracket u1 square minus v1 square, that will be equal to m2 in the bracket v2 square minus u2 square. This is our equation 2. Now if we divide equation 2 by equation 1, we can cancel out certain terms such as m1 and m2. Now the terms in the numerator can be split as u1 minus v1 times u1 plus v1. It is of the form a square minus b square, that is a minus b and a plus b. Similarly on the right side, so we can cancel out u1 minus v1 here and v2 minus u2 here. So you are left with u1 plus v1 equals to v2 plus u2. If we rearrange that, we can get u1 minus u2 equals to v2 minus v1, or the ratio v2 minus v1 divided by u1 minus u2 will be equals to 1. This ratio is defined as the coefficient of restitution denoted by small e. So we can define it as the ratio of relative velocity of separation to relative velocity of approach. It normally ranges from 0 to 1. So 1 will be when the collision is perfectly elastic. We don't need to do any derivation for inelastic collisions, because for inelastic collision the value will be less than 1, and we can go from there. So let us take an example now. A 5 kg mass moving at 6 meters per second makes a head-on collision with a 4 kg mass traveling at 3 meters per second. Assuming that there are no external forces acting on the system, what are the velocities of the two masses after impact? Assume coefficient of restitution as 0.5. So we have m1, m2, we have u1 and u2, and we need to find v1 and v2. So we will start with the equation for the coefficient of restitution. v2 minus v1 divided by u1 minus u2. In this case it will be equals to 0.5. Rearrange it and put the values here, 6 and minus 3, because they say about a head-on collision. Head-on collision will happen when the objects are moving in opposite directions. So 6 minus 3 will become 6 plus 3, and then multiplied by 0.5 will become 4.5. So we have v2 equals to, take v1 on the right side, v1 plus 4.5. Let us call this as equation 1. Now we have two variables, so we need two equations. For the second equation, we can take the conservation of momentum m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Substitute all the values and simplify it. We get equation 2. Now we have two equations, two variables. So we can substitute one value for V2 from equation 1. So we can put here V1 plus 4.5. Simplify it and we get the answer as 0 meter per second. And if we put the value here, we get V2 as 4.5 meter per second. It looks tricky at first, but the concept of coefficient of restitution actually makes problem solving much easier, and it makes the problem more realistic. You cannot always assume perfectly elastic collisions all the time, right? So coefficient of restitution, when we use it, we can get more realistic values that can be applied to day-to-day life. For more problems and their solutions, follow me on Solutions by Tall Teacher on Instagram. Don't forget to like, comment, share and subscribe to my channel. Stay tuned for updates.